Okay, lecture 3.3. So this is looking at dividing polynomials. All right, so we have a division algorithm. Our polynomial is the same thing as your divisor times your quotient plus your remainder. Okay, so your quotient, so divisor, quotient, and remainder. All right, so we're asked to do long division on this polynomial. Hopefully we've seen long division. If not, here's a good reminder. And we're going to express the answer in two different forms. All right, the first one we'll write in this form, and the second one we'll write in the other. All right, let's go ahead. So x minus 3, we're dividing that into 2x cubed minus 3x squared. We're missing the x term, so I'll just do plus 0x to keep a space there, and then plus 5. Okay, so if we're ever missing a power, I go ahead and add in that power with a 0 times the term, because 0 times anything is 0. All right, let's see. Well, we're just going to focus on the x. We don't really, sadly, the negative 3 is just sort of a byproduct. We don't really focus on the negative 3. So the question is, what can we times x by that would give me 2x to the third power? Well, 2x squared. Okay, and then we multiply that to our binomial, and we're going to subtract. So 2x squared times x would be 2x cubed, and then 2x squared times the negative 3 would give me negative 6x squared. Okay, and subtracting, those are gone. Negative 3 minus the negative 6 is actually going to be 3x squared. Okay, that was one cycle, so now we'll bring down the 0x and do the cycle again. All right, let's see. Now we're figuring out what we can multiply x by to get 3x squared. Now that would be a positive 3x. Oh shucks, I should have used that in purple. Oh well. All right, so let's do the subtraction again. Notice I like to use my parentheses a lot. I think it helps to not make as many mistakes with signs. All right, so 3x times x is going to be 3x squared. 3x times negative 3 is going to be negative 9x. Okay, subtracting, those are gone. 0x minus negative 9 would be 9x. So that was the end of one cycle. We have one more cycle, so let's bring down the 5. Last cycle. All right. What do we multiply x by to get 9x? Well, just by 9. Okay, and then do the subtraction. That times that's going to be 9x. 9 times the negative 3 will be minus 27. The 9s will subtract out, and then we have 5 minus negative 27. So that's going to be 32. All right, so let's see. Let's write out what, okay, so let's see. P of x is our 2x cubed minus 3x squared plus 5. So what is our divisor? Well, the divisor was the thing dividing into stuff. So that was my minus 3x. Sorry, x minus 3. My quotient is this guy right here on the top. And my remainder is the little guy down here, the leftovers, 32. All right, so go ahead and try to write out part A and part B by yourself and check your answer with me in a second. Okay, so part A, P of x is going to equal, let's see, my divisor is x minus 3 times my quotient, 2x squared plus 3x plus 9. And finally, adding my remainder, 32. Okay, B, let's see, it's going to be P of x over d of x, which should equal, so my polynomial divided by my divisor. That's going to equal 2x squared plus 3x plus 9 plus my remainder, 32, over my divisor, which was x minus 3. Okay, so there we go. Two different ways to show our answer. And that was long division with polynomials. Ooh, sorry, I had to sneeze there. All right, let's look at synthetic division. Okay, so long division is nice, but it is rather long. We got a lot of variables hanging out. We have to use a ton of space when we're working with it. So someone figured out, I forget who it was, some smart genius math person, not me, figured out how to use synthetic division. Okay, so this is used with a divisor in the form of x minus c. Okay, so notice x to the 1 power minus some number. So I'll show you how to do this. We're going to divide p of x by x minus 3. All right, so when we do that, first we want to figure out the number we're going to divide by. So we take our divisor, x minus 3, we're going to set it to 0 and solve for x. So x is going to equal 3. All right, so that's the number I'm going to be dividing by is 3. Okay, I'll set up my divisor this way. Here's the box I use for dividing. Next thing I'm going to do is write down all of the constant or the coefficients of my terms. Okay, so we start with 2. Then we have a negative 3. And notice I'm spacing them out, giving them enough space in between each of them. We don't have an x term, so I'm just going to write 0 for the x as that space holder. And then we have the last term is 5. All right, so to start this off, we bring down our first term to the bottom. Okay, and there's going to be a cycle, just like we had a cycle with the last one. So what you do is 3 times 2. So 3 times 2 is going to be 6. And you're going to write that next number you found from the multiplication right here. Okay, so first you multiply. Okay, and then we're going to add. Okay, so adding these two, negative 3 plus 6 is going to be 3. Okay, there we go. One cycle is done. So same thing's going to happen. We're going to multiply and then add. Okay, so 3 times 3 would give me 9. We're going to put that number right here, the next column over. And then we'll add. 0 plus 9 is 9. Okay, and then that was the end of one cycle. Let's start another cycle. 3 times 9 is 27. And then we add. And we're going to get 32. All right, so the question is, how do we rewrite this for our answer? Well, we're going to go ahead and choose B's form of the answer. So let's see. What is our end answer? All right, so one thing to notice is this one right here. If this is not a 0, if your final column does not end up being a 0, that is your remainder. Okay? The final column. All right, so what we're going to do is notice originally it was an x cubed. So when we rewrite it, it's going to be the next power down. So this is going to be a 2x. Instead of a cubed, we're going to go down one power squared. Okay, and then after that, the rest of them just follow x2, and you go to the next lower power. x2, then the next lower power. So this is going to be 3. What's the lower power from x squared? Just x. Then plus 9. I have no idea what that was, a negative. So I switched to positive 3. What's the next lower power from x to the first power? X to the 0, which is actually just 1. So there we go. So that's what we get when we divide it. That's our quotient. And then we're going to add to it our remainder, 32, and then our divisor, which was x minus 3. And notice, if you're paying, or if you realized, this is the exact same long division problem we did earlier, except instead we used synthetic division. So instead of doing long division, we did synthetic division, and we actually end up with the exact same answers. Okay, but synthetic division took up a lot less room than doing the long division. Okay, which is why we start to like using synthetic division. All right, next. Okay, so this is a good example for practicing synthetic division. Go ahead and try this one by yourself and check in with me in a second. All right, so for the synthetic division, let's figure out what we're dividing by. Set that to 0 to solve. So we're dividing by 1. Okay, setting up our division. We have 2. Do we skip any? We don't have an x term, so we're going to have to put a 0 in for that. Okay, minus 3, plus 1, 0, and negative 5. I don't actually have to put the plus 1. All right, let's check. 2, negative 3, 1, 0, negative 5. Yes, awesome. Got them all in. Okay, let's start by bringing down the 2. Multiplying. That's going to be 2. And then add. Remember, it's multiply, add, multiply, add, multiply, add. Okay, so adding those two, we get negative 1. 1 times negative 1 would be negative 1. Adding these, we'll get 0. 1 times 0 is going to be 0. Adding these, that'll give me 0. And 1 times 0 is going to be 0 again. And we are left with negative 5 plus 0, which is negative 5. And that is my remainder. Okay, so writing my answer out as quotient plus remainder over divisor. Let's see, how would I write this out? Well, it used to be an x to the 4th term, so we're going to go to the lowest one next, or the one lower down, which will be x to the 3rd power. That'll be 2x cubed minus x squared plus 0x plus 0 plus 5 minus 5. Okay? So our answer is going to be 2x cubed minus x squared, and then minus 5 all over x minus 1. All right, and that was our remainder. Okay, so our quotient plus remainder over divisor. All right, moving on. So the remainder theorem. All right, so if a polynomial p of x is divided by the binomial x minus c, then the remainder is going to be the value p of c, the inputted value of c. Okay, sounds rather strange and out there, so let's go ahead and do an example. All right, so use synthetic division and the remainder value theorem to evaluate this polynomial for c equals 1. And we'll check by direct computation. All right, so let's go ahead and do long division. So we're using c equals 1. Dividing into, let's say we have 2, negative 3, 1. We skip the x term, so we'll do 0, and then 5. All right, let's go ahead and do, oh, that's a negative 5. Okay, and let's do the long division. So bringing down the 2, multiplying 2. Adding will be negative 1. 1 times negative 1 is negative 1. Adding, we get 0. 1 times 0 is going to be 0. Adding those is 0. 1 times 0 is going to be 0. And adding those, we get our remainder of negative 5. So let's see. I'm going to check and make sure. If I take p of 1, so we're going to check this. So if I have p of 1, it should end up equaling negative 5, which is my remainder. This is what it's saying, is that if I input 1 into my function, I should get the remainder of negative 5. Okay, let's check if this is true. So p of 1, that's going to be 2 times 1 to the 4th minus 3 times 1 cubed plus 1 squared, and then minus 5. So that'll end up being, let's see, 2 minus 3 plus 1 minus 5. Oh, so that's going to be negative 1 plus 1. Yeah, it ends up being negative 5. It checks out. So the remainder, whatever is left over as the remainder, would be my answer if I plugged in my divisor into my polynomial. Okay, so let's go ahead and use it to check this polynomial again. Okay, try to do this example by yourself. Pause the video and check back in with me in a few seconds. All right, I'm going to go ahead and set this up. We have a missing one, so 0, negative 3, 7. We have another missing one, 0, and negative 5. Okay, let's start. 2, that's going to be negative 4, adding negative 4, multiplying 8, adding is 5, multiplying negative 10, adding negative 3, multiplying 6, adding 6, multiplying negative 12, and our answer is negative 17. So this is saying that p of negative 2 should end up equaling negative 17. So let's go ahead and check if that's actually true. So let's see, p of, we're plugging in negative 2, so that's going to be 2 times negative 2 to the 5th power minus 3 times negative 2 to the 3rd power plus 7 times negative 2 to the 3rd power, 2nd power, minus 5. All right. So this will be 2 times negative 32 minus 3 times negative 8 plus 7 times 4 minus 5. That's going to be negative 64. That'll be positive 24, positive 28, and negative 5. So let's see, that'll end up being 64 and 5, that's going to be negative 69. Plus, adding that, that's going to be 252, which equals negative 17. Yep, it's true. Our remainder here is what it would have been where p of negative 2 equals negative 17. All right, let's see. Next on the agenda is the factor theorem. All right, so C is a 0. I'll explain what that means in a second. So C is a 0 of P if and only if x minus C is a factor of P of x. All righty. Well, so that has to do with, so zeros are our roots of our equation, which is also our x-intercepts, okay? And remember, we get our x-intercepts from when we factor our, our equations into those binomial type forms. So we get our intercepts from these, or what we would call our zeros. All right, so we know, for example, x equals 2, if I pulled that from here, x equals 2 is a 0 if x minus 2 is a factor. Because, let's try an example. X minus 2. Would x equal 4 be a 0 of p? Well, no, because for x equals 4 to be a 0 of p, I'd have to have a factor of x minus 4 in here. Okay, so once I set it up like this with the x minus 4 in my p of x, then 4 is a 0 of p because its binomial is one of the factors. But if I take out that binomial, and so it's not a factor of p anymore, then that means that 4 is not a 0 of p. So the question is, what are the zeros of p? Well, we only have 2 when p is set up this way, and the zeros are 2 and negative 3. Okay. So if I took away this factor, the x plus 3, then p of x only has 1 0, so this one is no longer a 0. Okay, so it depends on the factors. So let's go ahead and show that p of 2 equals 0 and use the factor theorem to completely factor this polynomial. All right, so first we're going to check to make sure that that is actually a factor. So to check if it's a factor, that means it needs to be a 0. So 1, check if it's a factor. Okay, all right, so p of 2, we're going to use our polynomial here. It's going to be 2 times 2 cubed minus 3 times 2 squared minus 3 times 2 plus 2. Okay, go ahead and simplify that. Take a second. All right, so this is going to be 2 times 8 minus 3 times 4 minus 6 plus 2. 16 minus 12 minus 6 plus 2, which does indeed equal 0. Okay, so it is a factor because the remainder is 0. All right, let's go ahead and use some synthetic division. Okay, so this is going to help us factor. All right, so part 2, synthetic division. So we're dividing by 2. Setting up our factors, we have 2, negative 3, -3, and 2. We didn't actually leave any x factors out, so we don't have a 0 placeholder. Okay, let's start the cycle. Bring down the 2. Multiplying is a 4. Adding, that's a 1. Multiplying, that's a 2. Adding, that's a -1. Multiplying, it's a -2. Adding is a 0. Good. All right, so when we did that, remember 2 came from our factor that looks like x minus 2. So I know my polynomial, p of x, will equal x minus 2, right there. And then whatever this is, so let's see, that's going to be, it used to be an x to the third power, so I'm going to go 1 power down, x squared. So it'll be 2x squared plus 1x minus 1. And there is no remainder. So that 0 means we don't need to add on that remainder. All right, so let's see if we can factor this further. Well, we could use the, actually, you know what? This factors. So p of x is going to equal x minus 2, and this one factors into the binomial pair, 2x minus 1 times x plus 1. All right, so we have completely factored this. So now once it's completely factored, I can find my zeros, or what we would think of as our x-intercepts. And our zeros are going to be, actually, you know what? I'm not even asked to find the zeros, but we're going to go ahead and just point out the zeros. So the zeros come from setting these to 0. And solving. So x equals 1, x equals a half, and x equals 2. I have 3 zeros for this polynomial. Okay, but this was the factored form. So we like the factored form because I can pull off my zeros. Okay, so that's why it's important to know if something's a factor, because then we can factor it using synthetic division. And once we've factored it, then we can pull off our zeros, which are our x-intercepts, which are very important for graphing, and also just any application problems. All right, example 7. So we're going to use the factor theorem to completely factor this polynomial, and we're given one of the zeros. We know that -2 is a 0. Okay? So it's nice because at the moment we're being given zeros, but we're going to have to find the zeros ourselves later on, and we'll figure out how to find them. But for now, we're given our zeros. So, or at least we're given one of the zeros. Okay, setting up for long division. 2, 2, -6, -2, and 4. All right, let's go ahead. Bring down the 2. Multiplying, -4. Add, -2. Multiplying, 4. Add, -2. Multiplying, once again, 4. Adding, +2. Multiplying, -4. And adding is a 0. Good. That does mean that p of -2 equals 0. That was a good check there. So -2 is indeed a 0 because the remainder was 0. Okay, once I've done that, I found a way to factor. P of x is going to equal x minus the -2, which will be x plus 2. And then rewriting this. Well, the power used to be to the 4th. So once we've factored out one of those x's, it's just going to be down a power. That'll be 2x cubed. That's down 1 power. And then minus 2x squared minus 2x plus 2. All right, so let's see. Can we factor this? Well, that's 4 terms, so I think I can try grouping on it. Let's go ahead and see if we can try grouping to factor. Okay, so let's put the first 2 terms together. There's a minus sign, so when I do that, I have to be careful and change this one to a minus sign. Let's see, can I factor that? Take a minute, see if you can factor that. All right, pulling out the 2x squared, I'm left with x minus 1 minus, bring out the 2, x minus 1. Aha, they have the common factor of x minus 1 in them. So I can pull that out. And what's left over is this one and the minus 2. Okay. But you know what? I can still factor this. I can pull out that 2 from both of them. am I done? Aha, look at that. Difference of squares hiding out right there. We're going to have to factor that again. Whew, this one just keeps factoring and factoring. And that's it. They're all just regular old binomials. I'm going to go ahead and rewrite this so the 2's out front. And then I'll combine these x minus 1's.